Hi, so today is 30th June 2020 and exactly 150 days is remaining for the CAT 2020 also. And today we are going to discuss two questions from the algebra, basically from sequence and series. Okay. If you see the questions, both the question number 4 as well as question number 5, both of them are quite similar in nature here. One of them was asked in IMC 2001 and IMC 2002. So IMC, usually they for their one program that is known as postgraduate diploma in computers management, they used to conduct a separate exam in addition to CAT. So these are the questions from those paper here, and these are really important. On several occasions the questions from that paper was asked in the CAT and vice versa also. From the CAT, some of the question appeared in the CAT first and then in the IIM Kolkata paper and other way around. So pause the video for 5 to 6 minutes and then try to solve this question. Okay. And if you're not able to get the answers or the approach, then only you need to watch this video here. So let's start now. Question number 4. So it says summation of 1 by x square starting from x equal to 1. Okay, so this is the value of c. So if this is the value of c, let me write down all the values of c here. What is c represent here? C is equal to nothing but I can say 1 upon 1 square plus 1 by 2 square plus 1 by 3 square and so on. So let me write down a couple of more terms. 1 by 4 square plus 1 by 5 square plus 1 by 6 square and 1 by 7 square and so on till infinity. And what are we supposed to identify? We need to identify this term. 1 upon 2x plus 1 whole square of summation starting from x equal to 1. So what is this expression equal to? Let's see here. Okay. Now, if you substitute this expression is equal to what? If I put x equal to 1, what will I get here? This is 1 upon 2 into 1 plus 1 whole square. That is 1 by 3 square. So 1 by 3 square. At x equal to 2, the denominator will be 5 square. At x equal to 3, the denominator will be 7 square. And so on. 9 square. So sum of the squares of all the odd numbers, which is in the denominator here. So we need to identify this term. Now, if you observe here, 1 by 3 square. So this is the term 1 by 3 square. Then 1 by 5 square. 1 by 7 square. So all the terms which I have highlighted, like here I have highlighted 3 terms. So these are nothing but if you add them, then that is equal to the desired expression here. So let me say this value, it is equal to S. Okay. So I can say C is equal to 1 by 3 square plus 1 by 5 square plus 1 by 7 square plus 1 by 9 square and so on. Take all the odd terms outside plus 1 by 1 square. Write down the remaining term. Now remaining term, you need to pay attention here. This 1 by 1 square, this is not a part of the S here. So I need to write down 1 by 1 square. And then 1 by 2, 1 by 4, 1 by 6 and so on here. So 1 by 1 square plus, then I can say 1 by 2 square plus 1 by 4 square plus 1 by 6 square and so on, 1 by 8 square and so on till infinity. Now this expression till infinity, okay, this is what? This is equal to S, so write down S. This value, it is equal to 1, so write down 1 plus. Now, after onwards, starting from this term onwards, which term? I am talking about 1 by 2 square term onwards. Now, in this case, what is going to happen? I can write down 1 by 2 square. Okay, so what is 1 by 2 square? 2 is equal to nothing but 1 into 2. Or I can say that is basically nothing but that is 2 into 1. The other way around, you can write it down. So 1 upon 2 into 1 whole square. Next is 1 by 4 square. So 4 is nothing but that is 2 into 2. So 1 upon 2 into 2 square. Then next is 6 square. 1 by 6 square. So 6 is 2 into 3 whole square. Then 8 is nothing but that is 2 into 4 whole square. And so on till infinity. So if you observe here, what is here? The 2 is common, like this 2, this 2, this 2. The 2 is present everywhere and it's square. So you can take out 1 by 2 square as a common here. So this expression, it is equal to what? S plus 1 plus 1 by 2 square. I have taken it as common into 1 by 1 square plus 1 by 2 square plus 1 by 3 square plus 1 by 4 square plus 1 by 5 square and so on till infinity. Okay. Now, what is this expression is equal to, the which I have put inside the bracket? This expression is nothing but it is basically equal to C. We can see it here. C is equal to this entire expression here. Okay. So you can replace the term inside the bracket by C here. Alright. So let me replace here by C. So this expression, it will be equal to what? That will be equal to nothing but S plus 1 plus C, and in the denominator 2 square, that is equal to 4. So we have got finally that C is equal to S plus 1 plus C by 4. So solve this expression. What will I get here? That is C minus C by 4. It is equal to S plus 1. Okay. So this implies C minus C by 4 is equal to 3 by 4 C, which is equal to S plus 1. So what is S? So if we further simplify, S is equal to 3 by 4 C minus 1. So now just look at which option is satisfying. S is equal to 3 by 4 C minus 1. So the correct answer for this question is option B. So it was not a very difficult question. It is just a manipulation of this series and you'll get the answer. And in the CAT, they have asked several questions based on sequence and series. Okay. Now, let's move to question number 5. Now, since I have discussed the question number 4 right now, so again, pause the video and try to do it again, because I'm sure that if you understand the question number 4, you can easily solve this question here. Okay. And if you're not able to get the answer, then you can watch the video here. So pause the video, try it again. Alright, so now I'm going to discuss it. What is the value of P here? So here P, you can see X is starting from 0. So if we put 0, I'll get minus 1, 1 upon minus 1 square. If you put X equal to 1, again I'll get 1 by 1 square, and so on here. So let me expand this series and write down the value of P. So what is P? We can say P is equal to, when I put X equal to 0, I'll get 1 upon minus 1 whole square. That is same as, I can say 1 upon 1 square. When you put X equal to 1, then also I'll get 1 upon 1 square. At X equal to 2, I'll get 1 by 3 square. At X equal to 3, I'll get nothing but 5 square, and so on. 1 upon 7 square plus 1 upon 9 square and 1 upon 11 square, and so on till infinity. Now, what are we supposed to identify? We need to find out this 1 by x square here. So let's say this expression, it is equal to nothing but, I am saying this expression is equal to what? Let me write down this here. It is equal to S. So what is S here? So S is equal to, starting from x equal to 1. So I can say 1 by 1 square plus 1 by 2 square plus 1 by 3 square plus 1 by 4 square, and so on. So the series is till infinity. So 6 square plus 1 by 7 square plus 1 by 8 square, and so on till infinity. Alright. Now we can compare what are the terms here. So if you look at here, let me highlight that here. So this, if I look at here, 1 by 1 square, if I take all the odd terms, 1 by 3, 1 by 5, 1 by 7, and so on. So this is equal to this value, 1 by 1 square plus 1 by 3 square plus 1 by 5 square and 7 square, and so on. Remember, in the S, this 1 has repeated twice. So you need to be very, very careful in that case here. Alright. So now S is equal to what? So I can say S is equal to 1 upon 1 square. Write down all the odd terms one side, 3 square plus 1 upon 5 square, and so on till infinity. And all the even terms. So 1 by 2 square plus 1 by 4 square plus 1 by 6 square and 1 by 8 square, and so on till infinity. Now what is this expression is equal to? Let me highlight that which expression I am talking about. This expression. So this expression, it is equal to, remember, P, no, it's not P, but it is P minus 1. You can say 1 by 1 square plus 1 by 3 square, and so on. So this will be P. If you take out this 1 on the left hand side, then this expression is equal to P minus 1 here. So I can write down the term inside the bracket as equal to P minus 1. So this is P minus 1 plus. Now here again 1 by 2 square, take out common as we have done in the previous question. So it will be 1 by 1 square plus 1 by 2 square plus 1 by 3 square plus 1 by 4 square, and so on till infinity. And now what is this entire term equal to? I am talking about this expression. So this expression is again equal to S here. Okay, this expression is again equal to S. So you can replace this by S. So I can say this is equal to what? P minus 1 plus S by 4. And this is equal to S. So solve this, I'll get S minus S by 4, which is equal to P minus 1. So from here I can say that is 3 by 4S, which is equal to P minus 1. So this implies S is equal to nothing but that is 4 by 3 times P minus 1. So this is the answer. So which option is satisfying? Okay, I think that is option number 4. So the correct answer for this question is option number 4, which is 4 by 3 into P minus 1. So I hope that these two questions are clear and how to solve this type of the question. In the CAT, it's not necessary that the summation term will be there. They might give you, okay, if the value of P is equal to this, then find out what is the value of S. It's not necessary to use the summation term here. Alright. So I hope that this is clear to all of you. We have also started our free webinar, which is known as Freebinar, and we are conducting this webinar since 2013. So to know more about the free webinar or how to attend and where you can get the link of these webinars, you can join our WhatsApp group and the Telegram group, which is given in the description. Thank you.